like we've just ticked over to 15:01, so I will get started. What I'm going to be talking about today is some things that I've tried, and I hope we were all inspired by Peter this morning when he talked about the importance of experiments and the importance of failure, because what I'm going to show you today is almost 100% failure. So if you mark how good you are by how many failures you are, in this talk alone, I'm pretty much at genius level. So we'll see this as we go along. Let me start by telling you a bit about myself. My name's Holly Cummins. I work for IBM. I've been with IBM for about 15 years. I've just yesterday started a new job. I'm a consultant in the Bluemix garage, and so what we do is we help customers get going on the cloud using really innovative methodologies. Since I started yesterday, I can't tell you very much about how it's going yet, but I'm pretty excited. What I've been doing for most of my IBM career is I've been working on WebSphere in one form or another. And I've also written a book. So I've written a book on Enterprise OSGI. Should any of you wish to know more about Enterprise OSGI, there is your resource. I'm going to be talking about the Internet of Things today. And the Internet of Things, I think, is pretty amazing. And it's even more amazing when you look back to think where we were not so long ago. So this is a quote from Thomas Watson, who was the chair of IBM. And he said, in 1943, he said, "I think there's a world market for maybe 5 computers." And if we compare it to where we are today, where I've got 5 computers in my bag right now, a lot of us probably carry 5 computers around just in the course of our normal things. You know, we've got our phone, we've got our Kindle, we've got our laptop, we've got, you know, maybe something else. And so it's easy to look back and say, and laugh and say, ha ha ha, that Thomas Watson, wasn't he an idiot? He didn't know anything. But in fact, this prediction was correct for about 10 years. And I think most of us, if you could make a prediction that was accurate for 10 years, you'd be thinking yourself a genius again. And the reason Thomas Watson said we'd only want 5 computers was because computers back then were really quite large. You didn't put a computer in your pocket, you put a computer in a huge room, and the computer took up the whole room. Whereas where we are now, computers are so small, and computers are everywhere. So I ordered a new car recently, and I was amazed because I was reading the list of options, and it was things like, my car could tweet while I was driving. And I'm still not entirely sure that having a car that allows you to tweet while you're driving is a good thing, but it's kind of amazing what the technology can do. And you know, our washing machines have computers, our fridges have computers, our phones, obviously, they're not really phones anymore, they're just computers that occasionally we use to make voice calls. And I knew we were sort of getting towards the end of days when my fridge had a computer in it, and I thought the fridge should keep the food cold. And the fridge computer disagreed. So I said, please cool my food. Computer said, no. So that was a fridge I had a while ago. My next fridge didn't have a computer in it. I learned my lesson. And it's kind of exciting to have the fridge with the computer if you want your food to be warm. But most of these systems, you know, that even though they're very small, they're quite isolated. Whereas where we're going now is much more that there's embedded systems everywhere, and they're talking to each other, and they're able to make intelligent decisions. So, for example, the car talks to the fridge, and it says, Holly's on her way home. Perhaps now would be a good time to, well, I don't know what a fridge would do when I was on my way home. Talking to the oven's probably more sensible. You know, now's a good time to heat the oven. You know, talk to the fridge and say, now's a good time to fire out my instant meal from the fridge to the oven. So, you know, we're not there yet, but you can see we're getting to this point where the computers are talking to each other and making really intelligent decisions, if we're lucky. So just to step back a little bit, I think people have 2 reasons for being interested in the Internet of Things. One is because we can see the world is changing. We can see there's some really amazing business opportunities here. So how many of you in the room are thinking about Internet of Things in terms of how it will impact your business or your day job? 4, 5 hands. And how many of you are here because it's just so fun? A few more hands. And how many of you are here because there's only 2 tracks, so actually you thought both of these tracks looked pretty boring, but the other one was a little bit worse? Wow. None of you put your hands up, so you're probably just being polite. So I sort of had a sense of, I think most of you are in it for the fun. But let's see if we can be a bit more precise about that. And so this is where we start going from the theory to the practice and where we start going towards the failure. So what I did is I did a little bit of textile engineering, which you could call sewing, but I'm an engineer, so I like to call it textile engineering. So I did some pattern making and I did some cutting, and then I did some more pattern making and cutting. And what I ended up with at the end was this, which is that. And this is what I call the WebSphere sphere. It's the world's first throwable application server. I think it's probably also the world's last throwable application server, because really, why would you want a throwable application server? I told my mum about what I'd done, and she had exactly that reaction. You know, I said, look, Mum, it's amazing. She said, yes, it's very nice, but why on earth would you want to do that? I had to say, because it's there, Mum, because it was a challenge. So I wouldn't want to come and do a product pitch, because that's not cool, and you know, you're all paying to be here and you want to learn. But you may find that there's a small subliminal element of, or you may not actually, because really it sort of looks like the logo, but it sort of doesn't. So if I was to do it again, I'd do it differently. But there's a thing about when you work with physical things and with hardware as well, which is that with software, if you get it wrong, you just change the one line and you're good to go. Whereas with these physical things, if you get it wrong, I would have had to remake the whole sphere, and that was going to be way too expensive. So, you know, in software, we are actually quite lucky that we can fix things without having to retype the whole program. So what is this? Well, it's a ball, but it's also a computer case. So in here, I have a small embedded computer, and the computer is interfaced to some LEDs, which, oh, no, it's very sad. See, we are already at failure, because I was sitting outside the theater trying to make my demo work, and all day, one of these little blue sequins has been glowing. You'll notice none of these blue sequins are glowing now. So I think I managed to disrupt one of the connections when I tried to shove it into the sphere. And there's some cool techniques that I used in making this in order to get something which is squishy and cuddly to talk to something which is hardware. And the first of these, which I would totally recommend you go buy and play with, even if you're not actually that interested in playing with the Internet of Things, is this Conductive Thread. It's incredibly cool. You can sew with it by hand, you can sew with it in a sewing machine, you can solder it. It is really cool, and it's extra cool because it's only £6. So you can buy it, and then you can just sort of marvel at how flexible it is. And then you can go, oh, that was interesting. So it is very cool. It is solderable and sewable. So what have I done with my solderable thread and my fabric? I have what is a slightly unusual model for the Internet of Things, which is that I've taken my application server, and instead of having a very small computer doing almost nothing in the ball, I've got the whole computer in the ball. And this means I can connect to the ball, and it's actually running an application server. So let's see. I had a number of problems, and one of these was that I could get my computer to connect to the network. I could get the sphere to connect to the network. I could not get them able to see each other. So this is hosting, I hope, an ad hoc network, and I'm going to have to connect through that. So let's see. Oops. Oh. think we have a secondary problem, which is that I don't even have a network. So I hope I set your expectations low enough at the beginning. So the good news is now you get to see the innards of the non-functional demo. Yeah. I don't know if you can see, but there's not a single glowing light on that computer. And so that's going to be a problem for doing almost anything, really. So and if you thought watching people debug software during a presentation was fun, watching people debug hardware where you can't actually even see the hardware. So what I'm looking at is I've got a lithium poly battery. And these are really cool because they're not especially expensive. And for that volume, it will have enough power to power a computer working pretty hard for several hours. The main disadvantage of these for embedded applications is that they produce around 4 volts. And a lot of the embedded hardware wants to run on 5 volts. So that's what something like a standard mini USB charger will produce 5 volts, and that's what it expects. So what I've done, and this is after much experimentation, is I have this little guy here. It's called a power boost. And it takes in, it's kind of magic, it takes in 4 volts and it puts out 5 volts. And I've attached a little switch to it. And so when I turn the switch on, look, hooray! Oh, there's a loose connection somewhere. You saw the switch briefly, and it's flashing. That's no good. Yeah, there's a really loose connection here, so that's going to be my problem. So we have the triumphant blue light. And normally what I do is I throw this around the room, and that's really quite fun, but I think given the state of the connections, it's not going to stay up when I throw it around the room. But normally it's very cool because it can be flying around the room and it can be serving web pages at the same time. But the problem with this as well is loose connections are the bane of my life, because this is a pcDuino, and I used to use a Raspberry Pi. And with both of them, if you just wiggle the connection a tiny little bit, what happens? Of course, it's a computer. The computer turns off. And then it has to reboot itself. And so even though the power comes back nearly instantly, it's not a happy thing. But I do have a solution. So if you want to watch me debug hardware even more, it's like Halloween. Right. I have a secondary battery that I can use as an uninterruptible power supply, maybe. So you can see. If only. And one of the reasons I chose the pcDuino rather than the Raspberry Pi is that it has an onboard battery connector, which is quite cool. It's not as cool as I hoped, you'll notice, because I'm actually using an external battery anyway. But let me see if I can get this in. And the reason I'm using an external one is that this one only gives it 4 volts, and that's enough to power the computer, but not enough to allow the computer to do interesting and useful things like powering lights. So if I'm lucky, this will be a UPS, but I have a feeling I'm not going to be that lucky because I've already lost my blue light again. See, I tried to set your expectations so low, and I still didn't succeed in setting them low enough. No, it's not coming back, is it? Oh, it might. Well, I think I've got another loose connection now. I think I've got a computer, but I think I haven't got the connection to those. With the benefit of hindsight, it seems really obvious because what I've been using to connect these is I've just been using little breadboard pins. And most things that you read about them say, oh, well, they're good for prototyping and, they may last a few days. And I didn't read anything that says, and they'll survive being thrown around the room and stuffed into a cuddly sphere. So I probably should have been able to work out that I was going to have a robustness problem. So let me just carry on while that does its thing, maybe. So I've got to the slide of why did my demo fail. So you'll notice I was prepared. There's a couple of things that can go wrong in the physical world that we're just really not used to in the software world. So one of these is the short circuit. And shorts are particularly bad because the effect of a short circuit is basically just to kill the whole computer. And I knew this already, and I discovered it on Tuesday night because I was testing everything, trying to make sure it was all going to work. And I have a sensor on there, and what it does is as the ball is thrown around the room, each time it's caught, it flashes the lights and it says bounce on the web page, and it's really cute. And I was testing it all, and I smelled this burning smell, which is never a good sign. And then the whole computer just wasn't there. It wouldn't turn on. Nothing I could do would turn it on. And eventually I worked out that the reason was that the sensor had fried itself, and it had a short in it. So as long as the sensor was connected to the computer, that computer wouldn't turn on because it couldn't get any power. So this was a little bit stressful because I thought I wasn't going to have a demo at all. And in fact, I almost don't have a demo, but for different reasons. The other thing that can go wrong is the loose connection. And I'm very successfully demonstrating loose connections, as you can see, by the fact that it keeps turning off and on and it won't really power the lights. And these are really difficult to protect against, and they're particularly awkward when the whole system is sealed in a sphere. I had, the first time I did this, I've got the little LEDs and they wouldn't light up. And I thought, oh. And eventually I worked out that what had happened was that some of the circuitry actually inside the ball had come loose. And so I had to unsew the whole thing, unstuff the whole thing. And eventually what I found, I don't know if it's very clear in that picture, but this was a loose connection. And it wasn't a case where the wire needed to be wiggled a little bit. You can see I've got little silver hooks, and they're connected to the wires, except for one of the wires that had just completely snapped free. So that was a loose connection, and it wasn't going to be lighting anything. So one of the interesting bits about this is the change in the model. So I have a not particularly functional demo, but if it was running, what you would see is we've got a whole instance of WebSphere application server running in a ball being thrown around the room, and that's really something that we couldn't have even dreamed of even 5 years ago. And I think traditionally when we've thought about ubiquitous computing and the computers in the cars and the computers in the fridges, we've thought of really minimal devices that we had to run a really reduced programming model on. But now what we have is systems that are actually so powerful that we don't really need to change very much how we interact with them. So we can use the programming models we're used to. We can program them in a really friendly way. It may not be as fast, but maybe we don't need it to be as fast. So that's kind of cool. And I think one of the reasons this has happened, and one of the reasons it's interesting for the industry, is we do have a convergence now between what's going on in the cloud and what's going on in embeddable computing. Because it used to be when a business wanted to run their servers, they would have something on site. They'd have a great big computer, and it would be, it would be using maybe 10% of its capacity, but they'd be paying for all of its capacity. But now what we tend to do is we tend to put our systems out on the cloud, and someone else manages them for us. And what that means is that all of a sudden it matters a lot more how much resource these systems take, because we're trying to cram as many of them onto a single piece of hardware as we can. And there's a similar thing for elasticity. So it used to be that the system took the size it took, whereas now we really want it to be more flexible. And if we've got high load, then we want to be able to scale it up. If not, we want to be able to just keep it as small as possible. And that model that works really well for the cloud also happens to work super well for embeddable computing, which is, I think, why we see things that we didn't used to be able to do becoming possible. So let me just nip back out and see if it's come alive. No, it hasn't come alive. That's so sad. Yeah, it's got green glowing lights on it, hasn't it? But it's definitely not producing. Oh, yes, there it is. Aha. So. No. You know what I think has happened as well? I think this laptop has just crashed as well, which is, I think, partly why. Oh, actually, no, it can't have completely crashed. I've got a cursor over there. Right, let's not mirror the displays, because that's not helping. Hooray. So we're getting somewhere now. So what we can see is it's not actually serving my application that I hoped for, but it is serving me a 404 page. And if I yeah, you can see it's still coming up very, very, very slowly. So I think it might have had a few more little wobbles. You can see this is the my debugging for the unsuccessful bounce monitor. Hooray. So. Never has showing a web page been so exciting, but that's because never has showing a web page been so traumatic. So the interesting thing about this web page is it's not just a web page. So I'll do my little, I'll fill in my little survey. And the front of the web page is a JSP. It's using WebSockets and CDI to talk to a backend. I've got a JPA database. I've got JDBC. I've got a database running. I'm using JPA to talk to the database. So basically, I'm using pretty much every JEE programming model that I could think of. And I'm never sharing the sample code for this application, because basically what I did is I was trying to get it working, and I just sort of took all the examples I could find, and I went, I'll cut and paste this bit of CDI, and I'll cut and paste this bit of WebSockets, and I won't think about efficiency in any way. And that probably wasn't the right thing to do, because it's not a very fast application, but it does work, which is kind of cool, considering that it's running on a tiny little system. And you can see I've got a little temperature sensor here as well, and it has managed to produce a temperature reading. So that's kind of cool. And I can see as well, one of you has managed to connect to it too, which is really cool. Either that or 3 of you have connected and you're all called Ivan. I don't know how popular the name Ivan is here. Hands up if you're called Ivan. Yeah, actually, there are quite a lot of you. So now that we have demonstrated that it's sort of working, the other thing that it does, I don't know if it will do it. So I've got one light on here that's a power sensor, because when it's in the ball, you can't really tell what's going on. And the other 3 LEDs act as feedback about what's going on. So when you visit the web page, the LEDs flash. So if I do that type of thing. No flashes. So there's a loose connection. But you can see my temperature sensor is working. So it's showing that the computer's a fairly comfortable 15 degrees. And if I try again to put it back into the sphere, which I think I will do, since you've all seen it working, so you all believe me that it is possible for it to work. So oh, it's got tangled. I'm so looking forward to our wireless future, because I don't know if you probably can't really see unless you're at exactly the right angle. But I've got so many wires here, and I've managed to tangle them with the AV set up for this room. So, right, let's take that, and we will try and... There's a lesson here about engineering tolerances as well, because I don't know if you can see, but I thought I made the pocket plenty big enough for the computer, and it wasn't big enough, so I enlarged it, and it still isn't big enough. So double what you think you need, and then double it again. Right. I don't know if you can see this as well. This is one of the LEDs. So that would be why it's not working. So there's a lesson as well. If you do IoT things, make sure your joints are secure. Right, so it is in the ball. So let's just have a check and see, is it still working? I think it... No, I've killed it. Okay. Okay. Well, this will be the show and tell without the web page part, because you can still admire the you can still look at the ball. So I don't know. I'll pass it in. I think it just flashed actually as it was going along. So I think that might have knocked a loose connection into life. So. And the good news as well is, you don't have to be too worried about breaking it, because it's already broken. So I think this is really sort of cool, except for the fact that it's very unreliable. But I'm not sure if it's really Internet of Things. It's definitely not the traditional model. So we've got, I've got a thing. So I've done really well on the thing part, and it's embedded. So that's really cool. And it's very, very embedded. So even better. But normally when we think about Internet of Things, we think about the internet as well. We think about things talking to each other, whereas that thing only really talked to a client. So we haven't got any kind of machine-to-machine communication. And really, machine-to-machine is what we think about when we think about the Internet of Things. So I think there's a talk shortly after this one, which is going to be talking about protocols for the Internet of Things. My favorite protocol personally is MQTT. That's partly because it came out of IBM, but also partly because it's quite a good protocol. So I have a revised architecture, which is a more orthodox Internet of Things architecture. So I still have my sphere, but instead of running an application server, it's just running an MQTT client, and it's reading the sensors, and it's sending that information out to the internet. And it's also reading from the internet. So when someone accesses a web page running on the cloud, it flashes the lights. There's a few problems with this for this particular, yeah, feel free to have a peek inside. There's a few problems with this for this particular demo. One is that the sphere is running an ad hoc network, so it can't actually talk to the internet. The second is that it can't flash the LEDs because the connections have come loose. And the third is that the computer isn't even on. So if we leave all those aside, I think we can predict slightly the outcome of this. But it's still kind of, I think, useful to talk about. How many of you have heard of Bluemix? Hopefully all of you, since I mentioned it in my introduction. But so let me revise the question. How many of you had heard of Bluemix before I just mentioned it? Some of you. So Bluemix is IBM's cloud offering, and we've got a few things in there. So we've got infrastructure as a service. We've got platform as a service. So the idea is that you can send up your Docker containers, and we can run those for you with some extra services. Or you can just upload a WAR. And you say, CF push, it's based on Cloud Foundry, part of it. So you say CF push my WAR, and then it just goes off to the cloud, and then it's hosted for you, which is quite nice. And what was kind of cool, I thought, is that I managed to take the same source code, and it's running if the computer was up in the sphere, but it's also running on the cloud. So if I go to I need to go back to the real internet now for this to work. So I've got the same application, but it's running up on the cloud, and it can, if the computer were up, use MQTT to talk to the sphere, and that's all facilitated by services provided in Bluemix. So it provides things like a database to hold the answers, but it also has what they call the Internet of Things Foundation, and that's an MQTT broker. And so it means my Bluemix application can talk to the MQTT broker, my sphere can talk to the MQTT broker, and together they can do interesting things. So I'll just show you as well while I'm here. So if I go to So this is the Bluemix dashboard, and I can see that I'll be able to see my little application. I can see how much memory it's using. I can see what it's doing, and I can also look at the input from my sphere, except that I know there won't be any. Oops. Let's try that in. I think I've done something with my Safari cookies. It's not working entirely well. Try it in Firefox. Dag. You have those days when things don't start going well, they just carry on not going well. So I was going to say that, Bluemix, it's free to sign up and you can get a trial and you can do, I think, something like, you can host up to 2 gigabytes of application for free. But in fact, you don't need to, because now you can all use my password and you can go have a play with it. And you can, I've got the same term, so you can host up to 2 gig of application. And after all that, it's still not coming up either, is it? Never, 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 never do demos that rely on the network. Come on, you can do it. You can do it. Hooray. It's getting there. Slowly. So you can see down here I've got my application. And you can see that I've got 2 services hooked up to it. So I've got an SQL database that provides the storage, and I've also got the Internet of Things hooked up to it. But there's the potential for a lot of services that you could hook up to it, which is kind of cool. So, oh no, I'm not. I regret clicking on that link. It's going to take forever. Oh no, it's coming. It's coming. It's coming. So you can see it's designed as well to allow you to get started quickly. So you've got the Internet of Things starter, and then you can just take that boilerplate, and it's got everything filled in, and then it will be running on the cloud pretty much instantaneously, and then you can hook it up to your own spheres. So I've got as well, the way it works is that it provides all of the configuration you need in environment variables. And so you can parse this VCAP services and then use that to talk to your broker or to your database or to whatever else you like. So I've got a few, to close, I've got a few little tips on working with the Internet of Things. So the first is, if you're going to do this in any kind of work context where you do actually end up sending emails to colleagues or writing blog posts or that kind of thing, and if you're using a Mac, I would totally recommend taking the 10 seconds to fix your autocorrect and learn IoT, because I spent about 2 years, every time I typed IoT, it would change it to JOT. And then I'd have to correct it, and it was such a drain. So you can do that really easily. The only good thing about JOT is if IoT is Internet of Things, then JOT has to be Ginternet of Things, and I think we can all get behind something that involves Gin. But the second, the more serious bit is to get some hardware. Raspberry Pi is the classic. Raspberry Pi is really cheap. Raspberry Pi is really powerful. So the Sphere, wherever it is not a Raspberry Pi. But I have had lots of Raspberry Pis, and they've worked really well. What the Sphere is running on is a pcDuino. And there's lots of alternatives, but the pcDuino has the advantage that it's got onboard Wi-Fi, which can save a bit of hassle. And it also has, a Raspberry Pi uses an SD card, and that can be kind of slow. Whereas a pcDuino, it's got 2 gig of RAM, and it's got 4 gig of onboard flash storage. So it's really fast, except for today. There's lots of other options as well. I think the slides will probably be published, and I do have a walkthrough of some of the available options on there, and I'm also happy to take questions and talk you through some of the options and some of my experiences with them, because I have discovered almost all of the ways that all of them can go wrong. It's a special talent. So with that, I'll leave it. But we do have a coffee break now. So if you'd like to, I'm happy to try and reconstruct my loose connections, and we can see the lights on the Sphere flashing if you want to come and talk to me, because it is really cool when it works, when it's not. So thank you all very much, and please do well, first of all, one of you has the Sphere, so if whoever has the Sphere could return it to me. Oh, it's way back at the back. And yeah, please do feel free to come with questions or anything like that. And enjoy the rest of the conference.